Hi there, welcome to Chapter 5, Algebra Students. This is Mr. Dunaway, and we're going to jump right into things, keep things moving, hopefully for you. We have a lot to cover in this. This is a huge lesson for Algebra 1, so I'll encourage you to bookmark it and occasionally go back and look at it. If you don't know exactly what it is that we're doing here, you're going to have to be able to calculate this information quickly and accurately to survive this chapter. We're talking about something called rate of change or slope. You'll hear me use both of those phrasings. They mean the same thing. Rate of change and slope. And before we go on, as we get into chapter 5, you're going to need a straight edge in class, and you're actually going to need one in these notes here before we're done. I would recommend a small ruler, or you know what works great are your ID cards. So if you have that, grab it and just have it handy as we move through. You're gonna need it in, oh, I don't know, the second or third page as we move along here. So let's dive right into things here with number 1. It begins with the word rate, and it says which rate matches the situation. Ron reads 5 books every 2 weeks. Now, I really like the word per. And in my head, when I do things like this, if I can put the word per in there, it just kind of helps me know that that means division, and it's 5 books per 2 weeks. So the correct rate would be this one right here. It's 5 books per 2, because the other ones, this one it's flip-flopped, and this one has the wrong labels. It should be 5 books, not 5 weeks. So the one on the far right is your answer there. And number 2 is a tricky question that you may not be familiar with. And it's what it's asking you to do. It's saying, does the word always, sometimes, or never best fit these 2 words? A rate is a ratio. And it's interesting because some people think that a rate and a ratio are the same thing, but they're not exactly. Okay? They're not exactly. So let me tell you the answers, and hopefully they'll explain it as we get to number 3 here. A rate is always a ratio. All right, and I'll tell you what a rate is in a minute here if you don't know. And a ratio is sometimes a rate. And let me try to explain down here with number 3. It says underline the correct word to complete the sentence. Okay, well, a rate compares 2 quantities by division. All right, so, and a ratio does the same thing too. A ratio compares 2 quantities by division. But the thing that separates a rate and a ratio is this right here. All right, a rate compares quantities with different units. Different units, that's a rate. For an example of a rate would be like miles per hour. Okay, now that is a rate, and it's also a ratio. Okay, that's a rate and ratio. But the reason it's a rate is because a mile is not an hour. Okay, the mile is a distance, a measure of distance. Hour is a measure of time. Back here, the first example, this is a rate and a ratio. Okay, because you have books and weeks. These are different. Okay, now a ratio, the difference, a ratio, if it's not a rate, okay, let me say it this way. If it's not a rate, that would mean it would have the same units. Okay, so but it would be a ratio. For example, let me give you an example because it's so hard to explain. Imagine this is a TV, okay? And I'm just going to make up these dimensions. Let's say that this measure of the measure of length, I'll use the bottom line here. Let's say that is, I don't know, 80 inches. Okay, and then the measure of width is, oh, I don't know, let's say 35 inches. Okay, well, you could say this is 80 per 35. Well, they're both inches. So you see how the units are the same? So that would be a ratio. Okay, but it would not be a rate if you compared those two. So that's the difference. And why is this important in this particular chapter? As we do these things, what we're finding is the rate between 2 variables, how 2 variables compare. So those variables are going to be different as we go along. Sounds more confusing than it is. Huge word right here that you're going to have to know and you're going to hear me say all the time. Slope. Slope is the rise over the run, okay? Or it's the vertical change divided by the horizontal change. Okay, so that's division, rise divided by division. Another way that we write that, we could say delta y, that is a triangle. Y, that means change. Change in y divided by change in x. Okay, so again, the fraction means division. You've got to know that by now, that a fraction bar means division. So that symbol there means divide. You're taking the vertical change, you're dividing it by the horizontal change. That will give you the slope. And we're talking about if we are looking at a graph at this point. Okay, so that is the slope. Now, you can think of it, here's the definition. Okay, it's a ratio or rate, a ratio of the vertical change to the horizontal change. Okay, between 2 points on a line. Okay, slope is also called rate of change. This is really important right here, this definition. It says it perfectly for you. All right, a way to think about it is the steepness of a line, and you can obviously see them in hills, mountains, roofs, some roads as well. Okay, let's skip 4 and 5 because we're going to take some time on the rest of these, and I'd rather just jump into the material on your next page. Okay, so turn to this page here if you're not there already, the second page, number 6. At the top it says, finding the rate of change using a table. Now notice the phrasing they did there. We're going to learn how to calculate the rate of change. Again, rate of change is the same thing as slope, and you need to know that these are the same thing. I will use them interchangeably depending on the context of what it is that we are doing here. Interesting that they start you with a application problem, but that might be good for us to try to work through and see, calculate this rate of change here. And then we'll look at some what might seem like more simple problems in a moment. The table at the right shows the distance a band marches over time. All right, so you're looking at distance per time. The rate of change from one row of table to the next is, okay, so from one row to the next is 260 feet per 1 minute. Okay, so they're going at a rate of 260 feet per minute. So what they're asking us here is, do you get a rate of 260 feet per minute if you use non-consecutive rows on the table? And explain. So let's look at what they're trying to show you here. Here would be a really easy way to show you. I'm gonna, and you can do this too, plug in 0 here. At 0 time, consider how far would this band have marched? Well, 0, right? So when I go from 0 to 1, all right, so time went up 1 minute, and the distance went up 260. Okay, when I went from 1 minute to 2 minutes, time went up 1 minute, and distance, all right, we could figure this out up here, 520. They were at a total distance of 520. They were at 260 from the previous minute. If I subtract that, okay, I get 6 minus 2, 6, carry the 1, 4 minus 3, 260. So it does increase 260. So we can see right here, if I go from 0 to 1, that goes up 260. If I go from 1 to 2, that goes up 260. This question is asking, what if I skipped from here to here and compared those two pieces of data? Would I get the same rate of change, the same amount of distance that this is changing per minute? And that's what they're going to have us calculate here in number 6. So what I'm going to do here, just to help myself, is put up my shade and go one piece at a time. Now the rate of change, so here it is, the change in the distance. Now the distance, that's y, that's the y variable. Remember earlier how I said change in y divided by change in x? Okay, y is the independent, I'm sorry, y is the independent, is the dependent variable. Sorry, it's the dependent. It depends on how much time you've been marching. So x is independent, y is dependent. Okay, so here they're going to walk you through it. All right, now they've kind of left you some blanks and filled in some of the information for you. They have the y is 520 here for this order pair. they're at 520, so we're going to compare it to this ordered pair right here. That was 1040. And this 4 minus, okay, that is from this one right here. It was 4 minus 2. Because what we're trying to figure out is if I subtract these two numbers here and these two numbers, will I get the same rate as 260? All right, let me clean it up and clarify that one more time for you and see if it hopefully makes some sense to you. I want to find the difference of these two values here. And that's what I did on the top row. And then I want to find the difference of these two values and see, is it the same thing as when I did that between the first two rows. So if you subtract that out, 1040 minus 500 comes out to be 520, and 520 comes out to be 260 over 1. Okay, which means the rate of change is 260 feet per minute, which was the same thing we got when we compared 1 minute to 2 minutes, and the same thing they told us in the initial problem. I'm way over time here, so I need to stop this video and pick it up here in a moment.